For this one, this is going to be a cube root function, and we can tell because on the radical there is an index number of 3. So this time it's going to be cube root, which means it's going to look like that second one with a little S-curve in the middle. Once again, we're going to identify the transformations before we begin trying to graph it. So this one has a 2 in front, like the A value, and the A value is a vertical stretch or compression factor. Because that number is greater than 1, that is a vertical stretch. By a factor of 2. There is nothing inside the radical with the x, so that means there is no horizontal translation going on this time. The minus 3 there is outside of the radical, so that's going to be a vertical translation, and the vertical translations happen exactly as they appear in the equation, so that's going to be down 3 units. Okay, so now I'm ready to start graphing my function. I'm going to use some points from the parent function, starting with the origin 0, 0. If I take that point 0, 0 and I stretch it vertically by a factor of 2, that means I'm multiplying the y value only by 2. 0 times 2 is still just 0, so the point is still at 0, 0. Then I'd move it down 3 units, so 1, 2, 3, and that would put me at 0, negative 3. The next point from the parent function would be a 1, 1. To stretch vertically by a factor of 2, I'm multiplying the y value only by 2, so that would put that point now at 1, 2. And then I would translate it down 3 units, so 1, 2, 3. That would put me at 1, negative 1. Next nice point from the parent function was 8, 2. If I stretch that vertically by a factor of 2, I'm multiplying the y value only by 2, so that would be 8, 4. And then I move it down 3, so that would put it at 8, 1. Now with this one, there were a couple of points in the third and fourth quadrant also. So there was a point at negative 1, negative 1 on the parent function. When I stretch that vertically by a factor of 2, I'm multiplying the y value only by 2, so that would put it at 1, negative 2. And then I translate it down 3 units. 1, 2, 3, that would put it at negative 1, negative 5. And then one more, negative 8, negative 2. Stretch that vertically by a factor of 2 by multiplying the y value only by 2. So that would put it at negative 8, negative 4. And then translate it down 3 units. So that would put it at negative 8, negative 7. Then I can use those points kind of as a guide to get my picture. It's going to maintain the same shape as the parent function. Oops, I missed on that side. I'm going to try that one again. Maintains the same shape as the parent function, but it does look like it's been stretched vertically by a factor of 2 and shifted down 3 units, which is what we expected. Okay, so the domain on this one. On the parent function, the domain is all real numbers. So no matter what transformations I do to this, typical transformations anyway, the domain is still going to be all real numbers. For the range from the parent function, the range is all real numbers also. So again, no matter what transformations I do to it, that's going to maintain as the range. It's still going to be y can be any real number. Okay, now answer the questions on the Google form.